Hey, it's OG Math Mosley, and today we're going to be looking at density curves in statistics. So let's get started. All right, so in statistics, this is what a density curve is. A density curve is a curve that is always on or above the horizontal axis, or the x-axis, and has an area exactly 1 underneath it, right? A density curve is often a good representation of the overall pattern or shape of a distribution. Just remember, the shape of a distribution is one of the key things we always want to describe when we're describing a distribution. The area under the curve and above any interval of values on the horizontal axis is the proportion of all observations that fall in that interval. All right? So it allows us to kind of quantify how much of our data is within a certain range, and we always know that 100% of our data lies under the density curve and above the x-axis. Right? So we have a couple little examples set up here just to show what a density curve can look like. This first one here, we have a approximately symmetric distribution. All right, it ranges from 0 to 18. It represents the missing assignments per student. I left off the y-axis for the frequency here because I'm not terribly concerned about the frequency for these examples. Generally, you would want the frequency so you can quantify things. However, for the sake of just showing what a density curve is, I didn't feel as though it was terribly important. Right? So within this distribution here, the density curve will draw over the distribution. Right? We'll try to mirror this curve as best as we can. Right? So that density curve covers all of my data. Right? Now, it doesn't need to be perfect. I'm pretty happy with this one. It turned out pretty consistent overall. Generally, I just have a hard time doing it, but you should cut off some of these boxes so that some of the edges are a little bit cut off. And then some of them you kind of go over, like because we're counting this here, and that's obviously not part of the area. But we get the general idea. This is the shape, and underneath it is 100% of my data. Right? This other example here obviously is skewed. It's skewed to the left because that's the direction our tail is in. It represents the scores on a quiz. Right? Distribution of scores. They range from 1 to 8. All right. And in this case, I'm not going to like curve the tail here. I'm going to just allow it to progress up. And this time I'm doing a better job of cutting off some of these. So we go down here, right? And again, we can see that this is skewed to the left, right? Our tail is going to the left here, all right? And so again, 100% of my scores lie under my density curve. So the density curve shows the shape, and then we can also use it to represent proportion of data. Right? If I knew the counts of these things and I was like, okay, well, what proportion of my scores are less than 7, I would count up how much out of my total number of scores lie less than 7, and that would give me the proportion. All right. Something useful to know about density curves, right, is that in a symmetric density curve, such as the one here on the left, the mean and median will both be in the same place. Right? They'll be in the middle. Right? We'll have the mean and median right in the same location. That's because we're balanced here, right? The median is the point, right, where it splits the amount of data in half. Half of my data is to the left of the median, half of my data is to the right of the median. All right? It's the equal split point. The mean is the balance point. It may not be exactly at the equal split point unless we're symmetric. All right? When we have a skewed distribution such as this, right, the mean will be at the balance point, all right? And the median will be at the equal proportion point. So I'm going to kind of guess here just based on boxes, like because we're going on the kind of like volume almost. Right, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15, 16, 17. Half of 17 is 8.5. So if I go 1, 2, 3, 4, 5, 6, 7, 8 8.5, right? So there's 1, 2, 3, 4, 5, 6, 7, 8, right? So my median will be about right here, right? However, the mean is going to get pulled to the direction of the tail, right? Outliers, extreme values, the way that the skew is will pull the mean towards the direction of the skew, right? So we can probably just guess without doing much work here that we can guess that the mean is going to be to the left of the median because that's the direction of the skew, and we'll guess maybe somewhere around here, right? And that pulls in the direction of the skew, right? So that's some properties of density curves, right? We know we can guess where the mean and the median is based on the curve, right? And we know, again, one of the key things is that the proportion, the area under the curve has to be 1, right? And that we can kind of know some things about this, right? We can start talking about proportion of my data, what amount of scores are less than 6 or greater than 6, or what proportion of students have more than 12 missing assignments. I can start using this data more to talk about proportion, and then I can use that in the probabilities and go beyond just the statistics. A more useful and common density curve is the standard normal curve or normal curve and a normal distribution, which we'll get into on the next video. All right, if you have any questions or comments, please let me know. Other than that, we will see you next time.